Okay. So what is the Coulomb's law of electrostatics? What is Coulomb's law of electrostatics? Yeah, the force of attraction or repulsion between two charges is directly proportional to product of charges and
inversely proportional to the distance between them.
Very good. So that is Coulomb's law of electrostatics. What is the formula? Sorry, what is the formula?
1 by 4 pi epsilon 0 q1 q2 by r square r cap.
Yeah, 1 by 4 pi epsilon 0 into q1 q2 by r square. So what is 1 by 4 pi epsilon 0?
Kappa.
1 by 4 pi epsilon 0 is what? 9 into 10 to the power of 9 coulomb Newton meter square per coulomb square. And epsilon 0 is what?
8.85 into 10 raised to
minus 12 coulomb square per
minus
meter.
12.
Okay, that is the value of epsilon 0. What is epsilon 0? What is epsilon 0?
Permittivity.
Permittivity of free space. Okay, what is the permittivity of free space?
It's the property of the medium to allow magnetic field lines to pass through it.
Electric lines of forces to pass through it. That is said to be
pass through it.
That is said to be permittivity of free space. Okay. Next, then we have what is that? System of particles. Suppose there are system of charges. Then what is the force then? System of charges. What is the force?
So superposition principle.
Yeah. So superposition principle. What is the superposition principle? So F is equal to what? F1 plus. What is F1
F2
and F21? Force on 1 due to 2 is F1.
Due to 2.
And F21 is force on 2 due to 1. Okay. Now, if there are so many charges and if they're exerting a force on one particular charge, then we can add all the forces. F is equal to F1 plus F1 is equal to F12 plus F12 plus F13 plus F, well, like that keeps on going. We have a simple formula, summation formula they have given. And after that comes electric field. What is electric field?
So it's the field around a particle where its electric influence can be felt.
Field around the charge where its influence can be felt is known as electric field. And what is there is one more definition. Force experienced. Okay, the force experienced by a unit positive charge when it is placed under the influence of charge q is said to be what? Is said to be electric field. Okay. Now we have what is the formula? E is equal to what? E is equal to 1 by 4 pi epsilon 0 q by r square. Okay, that's a formula. After that, we have there are what is the unit of force and field? What is the unit of force and field? Can anyone say?
Coulomb.
Force. Electric force is measured in. Electric force is measured in newtons, and electric field is measured in. Electric field is measured in what?
Sir, Coulomb, right?
Electric force is measured in newtons. Electric field is measured in Newton per coulomb.
Newton per coulomb.
This is our revision. Okay. Now, next one. So we have okay. What are the? Can you tell me the properties of electric field lines? There are total how many properties? 5 properties.
Five
properties. Do not intersect each other.
5 properties and significance also there are 3. I think that 3 or 4.
Yes,
okay.
sir.
First, tell me the properties.
They are normal to the surface. They do not intersect each other. They do not form closed loops. And like charges repel and unlike charges attract.
Not that one. Can you tell me? They start from positive and end at negative. They start from positive and end at negative. They are continuous curves. They do not form closed loops. They are normal to the surface. And what is the next one? Go through. There are total 5. Yeah, they never
intersect each other.
They never intersect each other. These are the total 5. What is the significance now? Significance of electric field lines. Quick. I have to complete this chapter today. Then only I can start new lesson tomorrow. Yes. What about you, Moksha, Durti? You are just keeping quiet. Ismail, there's no answer from your end. What is
Sir,
the
they provide a mean to visualize the electric field.
what is it?
They provide a medium to visualize the electric field.
Is it like that? Did I say that one yesterday? In physical significance, what I said, when a charge accelerates in the body, what will happen in a metal or in a conductor? What happens? Electromagnetic wave is produced. That electromagnetic wave travels with the speed of light, and it exerts a force on the second antenna. It exerts force on the second antenna or other body. There, the charge is detected, the field is detected, or whatever it is. And second one is what? It has dynamics of its own. I gave the example of Gajini also. You remember yesterday? It has dynamics
Yes,
of
sir.
its own. So the role played by mass in linear motion is same as the role played by moment of inertia in rotational motion is also same as the role played by electric field in electrodynamics. Clear? So that is the second one. Third one is it can transport energy. These are the physical significance. This can be made as assertion reasoning question in your exam. So
why does it exert a force on the second antenna?
Yeah, the electromagnetic force they exert, right? They are carrying energy, right? They carry
Yes,
energy. This electromagnetic waves, they carry energy, and they exert a force on the charge. They exert a force on the charge which is present in the second body. Correct?
Okay, sir.
That is
Yes,
how the electromagnetic waves are detected. Okay, clear?
Yes, sir.
Now, next one is what? Yeah. Okay, so the next one we have electric. What I was teaching yesterday, electric field and electric dipole. What is electric dipole?
So two equal and opposite charges separated by a finite distance.
Yeah, two equal and opposite charges separated by a finite distance is said to be electric dipole. What is electric dipole moment?
Two equal and opposite charges placed at a distinct distance.
Yeah, the product of force and displacement with me. Oh, sorry, the product of charges and the distance between them.
Either of the charges and the distance.
Yeah. Yeah. So now here we have electric dipole. So we will start with the derivation. Okay. So we'll speak about axial line and equatorial line. Okay, we'll finish off that today. So axial line in equatorial line. So electric field. Right here, electric dipole moment. The field of an electric dipole for the field of an electric dipole
So I think before that electric flux comes, right?
It's okay, that I will teach later on. Okay, after this.
Okay, sir.
Electric dipole, the field of an electric dipole for points on the axis. For points on the axis. For points on the axis. So what happens here? So suppose there is a positive charge here. This is a negative charge. This is a dipole plus q, and this is minus q. The distance, 1 second. No. So plus q and minus q, and I want to at point P, I want to find out the electric field due to the dipole. What happened? You started wearing them? In India, it is not here.
What's that?
So now the distance between both the charges is what? 2a. I want to find out on the axial line. Axial line means what? The line which passes through through both the charges. Okay, the line which passes through both the charges is said to be axial line. This line is said to be axial line. This line is said to be axial line. Now at point P. So now You take. You correct it? Yeah. No, I didn't correct. I'll correct it today. Okay. Okay. So became lazy man. That's the thing. Otherwise, I would have done long time back. Now this is from the center. So from here to here, it is what R. Okay. From the center, this is the center. From the center to this point P is R. So this distance will become what? This will become. This is A now. This half of that is A. So what is that? R minus A. This is R minus A. And this one is what? R plus A. Is that clear, all of you? See, this is a dipole. This is a plus Q minus Q is a dipole.
Yes, sir.
And between both of them is 2.
Yes, sir.
At point P, I want to find out the electric field due to both the charges, positive and negative charge, means dipole. Now, half of that is A, and the distance from the center to point P is R, and the distance from positive to P is R minus A. Then from here P to the minus Q is R plus A. Okay, so we have electric field here. So the formula is what? Electric field due to positive charge. E is equal to what? 1 by. Please tell me. Don't be just quiet in the meeting. Q by
1 by 4 pi epsilon 0 Q by
this is tell me.
R plus A the whole square.
R, the distance from here to here is how much? R minus A whole square only, not plus AC.
R minus
Here to here.
Yes,
This
sir.
is the electric field outward. Due to positive charge, it will be outward because we have placed a unit positive charge here. I told you yesterday, unit positive charge is only one charge, which is not there in the universe. It is a hypothetical phenomena, but we want to just experience how much force is experienced by positive charge. Okay, so now, okay, so